This is the ferrofluid experiment created by students at the ISSET Mission Discovery event in 2021. The students invented an experiment and presented it to judges who selected it and had it built by postgraduate students at Oxford University and a member of Foale Aerospace. The experiment will fly to the ISS, hopefully in November of 2022. And this is one of 2 units being built. Either one may fly to the ISS. The ferrofluid experiment consists of 2 magnetic coils that are energized by a supercapacitor that provides the current. The magnetic coils are in the back, that's called L1, and in the front, L2. Between the coils, underneath this perf board, there is a tube of ferrofluid, and it's able to move either towards the back coil or to the front coil when the magnetic field is applied to the coil. If the ferrofluid moves, and that is the question the students are asking about flying this experiment in microgravity on the ISS, if the ferrofluid moves, there is a sensor coil in the middle that will detect the presence of the ferrofluid because it will change the magnetic properties in that region of space. The experiment is controlled by an Arduino. The Arduino Nano is also controlling the micro SD card data writing. Data, once it's been recorded to the SD card and the experiment is finished, will be returned to Earth by returning the SD card in an astronaut's belongings or in a return to Earth cargo shipment. The ferrofluid activates after about 10 minutes when the supercapacitor is fully charged to 2.3 volts. At that point, the Arduino begins the sequence that repeats every minute, activating the relays to close to energize first the back coil 3 times, separated by half a second and 1 second duration each time, followed by a minute, and then the front coil, we call it L2, is activated by the Arduino, 3 activations of the relay, 1 second for each activation, separated by half a second. This way, we are hoping, or the students are hoping, that the fluid is able to be shunted either to the back or to the front, or to the back or to the front. And if this demonstration is successful, the application of this ferrofluid experiment may lead on to other methods of moving fluids around in space, in microgravity. The clicking you hear when the activations are occurring is coming from the relays that are turning on and off the current to the coils. That was the back coil being activated, L1, with a south pole at the back and a north pole in the middle. During a discharge of the capacitor voltage drops from 2.3 volts to 2.2 volts, i.e. a 0.1 volt drop. The capacitor's value is 25 farads, so those physicists amongst you can calculate how much charge was delivered using the formula Q equals CV. And that was the front coil, L2. So in summary, the sequence of coil activations is the aft end where the supercapacitor is. That outside end will have a south pole. There'll be a north pole in the middle. There will be 3 bursts separated by half a second each, and each burst lasts 1 second. After a minute of recharging the supercapacitor, the cycle of bursts, 3 bursts, is repeated at the front, the L2 coil. That is the L1 coil being lined up with south. And now, after another minute, we will have the L2 coil. The experiment, once it has been activated by putting in the batteries, can be left attached to the wall in the ISS using Velcro. And it can be left for as long as the astronauts are able to leave it. The batteries will run down after 24 hours. However, we expect a data take to be sufficient in just 1 hour. And that was the L2 coil being activated. This is the end of the ferrofluid video demonstration.